All right, so this week we're going to take a look at 3 sections, 7.2, 7.3, 7.4, and it's on what we call logarithms. So here's a simple equation. It says 2 to the x equals 8. You want to tell me what the answer is?
2.
X equals 3, yeah. 2 cubed, 2 times 2 times 2 gives you 8. How about this one? X equals 2. 3 to the second power, or in other words, it's 3 times 3, gives you 9. Okay, so not bad. What makes this one a little harder? I mean, all I did was change it from 2 to the x equals 8 to 2 to the x equals 9. They make a huge change. Yeah. Yeah, this isn't a power of 2. 2 cubed is too small. So x being 3, no, that'd give you 8. X being 4, that's too big now. So the answer is now somewhere in between 3 and 4. And it's not something you can guess easily. Right? Especially if they asked you for like 2 decimal place. Right? It's going to take forever to keep trying numbers to figure that out. So anytime that we have a variable as an exponent, that's a problem that would have to be solved with a logarithm. Right? So that's the kind of problem you guys will see eventually. So all of the things that I just wrote down on the board, 2 to the x equals 8, 2 to the x equals 9, those are called exponential expressions. Exponential expression, very, very simple definition. It's any expression that has a variable in the exponent. That's what makes it more of algebra 2 than algebra 1. In algebra 1, you don't have variables as exponents. You might have something like this. That's totally different. And I'm not saying in algebra 1 you don't ever have exponents. You might have exponents, but you don't have variables as exponents. So any expression that has a variable as an exponent. What do you call that number? The number that's lower. Remember what you call it? Well, what do you call the number that's higher? Anytime you write a number that's a little higher than something else. We've already said, yeah.
Exponent.
That's an exponent. Yep. That's your exponent. And what do you call the thing that's below the exponent?
Base.
Yeah, the base. So I'll use the word base a lot today. So the base, I just think of the base as it's lower, right? Because the base is usually on the bottom or something. So it's lower than everything else. So anytime we want to solve an exponential, you wouldn't really be solving exponential expressions. You'd be solving equations. There's nothing to solve unless you make a problem with an equal sign. Like 3 to the y, you can't solve that. 3 to the y equals what? You got to put equals something. So if I put equals and then I wanted to solve it, the way we're going to do it is we're going to change it to something with a log. Right? And most of the time, you're going to need a calculator to do logs. Okay, my calculator has 2 buttons for log. One says log, one says ln. Those are both logarithms. The calculators that you guys borrow have the same 2 buttons. One says log, one says ln. Okay, I'll explain what each of those mean in a second. All right. So first thing, when we write a logarithmic expression, let me show you one with all numbers. It's going to look something like that. Okay, you don't have to write that yet because we're going to get to it. But that's what it'll look like. If you were putting that on lined paper, it would look like that. So the y, the equals, the log, and the x, they're right on your line. The a is below the line. Okay, so the a is actually like a subscript. It's lower than everything else. So that might give you a hint at what I'm going to call it. I just said a second ago, what I always call the thing that's lower than everything else. There is no exponents in that problem. Some people think, oh, well, isn't the x an exponent? No, the x is on the same line as everything else. That's an exponent. Okay, now that it has something higher. Okay, but if I just write it like that, just write it like that, no exponent. All right, so I'm going to show you guys the formula to change between something that's called exponential and log. Those are the two things we're going to change between. So an exponential looks like this. Usually you've got a number equals another number and then a letter. Just like that. Number equals another number and then a letter. Well, if you have something written as an exponential, you can move some things around and convert it into a log. There's no math, there is no calculation you have to do. It's just a matter of looking at what goes where when you move it. All right, so first thing, anytime you want to write something as a log, you've got to write down the word log. Okay, so we're going to have a log. Okay. Next thing we're going to look at is the A. Anthony, since the A is lower than the Y, what did we call the thing that was lower?
Yeah. I'm not sure.
Want to help him out? Yeah.
That's the base.
It's the base, yeah. So, looking at what's on the left, A is called the base. Looking at what's on the right, A is also called the base. And I'm going to tell you that when I show you how to read or pronounce what's on the right. But A is the base because it's lower. A is the base here because it's lower. All right. Next thing you want to remember. Logs always equal exponents. That's what a logarithm does. It enables you to find an exponent. Like in any of these problems, solve for the exponent. So logarithms always equal exponents. Look at the right hand. Well, actually, look at the left hand side. Y is the exponent. A logarithm should always be equal to the exponent. That's why the y is by itself, because the y is the exponent. So logarithm always equals the exponent. So on your calculator, if you typed in something like log of 78, that number 1.89, that's an exponent. An exponent on what? Well, I don't know. I'd have to know the whole problem of what I just solved. But that 1.89 is an exponent for something. All right. So number that's lower is the base. Number that's lower there is the base. Logarithms always equal the exponent. Okay. Last thing. This is called the argument. All functions have arguments. Argument is just a fancy name for the thing you plug in. That's all. So like when we did stuff like sine of 15 degrees. 15 degrees is the argument. It's the thing you're taking the sine of. Square root of 6. 6 is the argument. It's the thing you're taking the square root of. It's just what you're plugging in. Right, it's the same thing here. This is the argument. Now, what happens if you argue with someone all the time? What's going to happen? They're going to what? You're going to win? You haven't argued with me. I'm just kidding. Don't tell my wife that. She'll just roll her eyes. Somebody else, what happens if you argue with somebody all the time? Yeah, you're not going to be friends. You're going to annoy them. You're going to end up alone. That's why the X. That's why the X is all by itself. Okay, so if you argue, that's how I remember it. If you argue with somebody all the time, you end up by yourself. Okay. So the argument ends up all by itself on that side. Okay? So if you remember that, and you remember the trick about the base always being the number that's lower, and logarithms always equal exponents, it tells you what's going to go where. All right. Now, on the right, the way you pronounce that, or the way you read it, I mean, the first part is pretty simple. Y equals log. And then the last part is base A of x. So you read it left to right. Y equals log base A of x. You pretty much have to say every word there, except you could leave out the word the. But you got to say y equals log, you have to say base A of x. That's how you say it. So what we're going to try at first, we're just going to change something that's exponential to log, and then we'll try changing log to exponential, just between the two. And then eventually we'll use that to try to solve an equation. Okay. Any questions on, I'm going to have the formula. And I put an arrow on each end because you can go either way. Exponential to log, log to exponential. Works whatever way they want you to do it. All right, so this one says change to exponential. So that means when we're done, we're not going to have the word log anymore. All right, let's start with the 3. The 3 is lower than everything else. So that means the 3 is my what? 3 is my base. So I'm going to start with that. It's going to be the base for something. So that means I'm going to have an exponent up here. Now, just a minute ago I said logarithms always equal what kind of number? Logs always equal exponents. Logarithm equals, there's your exponent right there. And what do we call that? It's the argument. It's the thing that you're taking the log of. Right? So if you were typing this in on a calculator, you'd hit the log button and then you'd type in whatever x is. And what happens if you argue all the time? You're going to end up alone. You're going to annoy people. So the argument ends up alone on the other side by itself. Now, some people have said, well, could I do this? What do you think? Yeah, it's the same. Doesn't matter which way you do it. Now, that's it. We're done. There's nothing there to solve. The only way you could solve that is if I said to you what y was. Like if I said y was 2. Then you could do it out. 3 to the second power would give you 9. Okay. But unless you had a little more information, you can't go any further with that. Okay, let's try this one. Okay, first thing I want to see if just somebody could just pronounce that. Like if you have to just read it off. Megan, could you read off what example B says?
Y equals log base 5 of x.
Perfect. Exactly. Y equals log base 5 of x. So by her pronouncing it, she just told me what the base was. Oh, base 5. So I got the base. Gabe, logarithms always equal what kind of number? Not sure. Steven, can you help him out? Put an asterisk right over here earlier, and I said logarithms are exponents. So logarithm always equals my exponent. So what's my exponent here? Y. Logarithm always equals the exponent. Now really, there's only one thing left, and there's only one spot to put it. The x is all that's left, and the only space is on the right-hand side. So the argument ends up by itself. And that's the answer. Again, nothing else you can do with that unless you knew what y was. But that's all I want you to do. Any question on changing exponential log to exponential. Let's try the other way. Now we're going to take something that's exponential and make it log. If I'm going to change something to a log expression, what do you think the very first thing I should write down is? This is what makes something a log expression. Yeah, put down the word log. Write the log. Log is a function, like sine or cosine. Yep, perfect. So write the word log. Right. Brandon, logarithm always equals what kind of number? Exponent, perfect. Logarithm always equals your exponent. What's my exponent up there? 3. Yep. Logarithm always equals the exponent. Next thing I need is my base. Riley, what's my base on my log?
1.2.
1.2. 1.2 is the thing that's below the number that's higher. That makes it the base. 1.2. And the last thing I need to fill in for my log is the argument. What am I plugging into the log function? Look for the thing that's by itself. M. And that's your answer. And again, nothing to solve. You're not trying to figure out like what M is. Just changing it to a log expression. Questions on that one? Let's try this one. E to the B equals 9. Now there's something happening here that you don't know yet. But it doesn't matter. It doesn't affect how you're going to do this at all. We'll do it just like we did the last one. And then I'm going to come back to this after I show you something. Right. So Alyssa, when we're changing to log form, first thing we got to write.
Log.
Put the word log. Log. Yashira, logarithm always equals what kind of number? Always equals your exponent. What's my exponent there? B. So we got that. The base is what? E. The base is E. And the last thing we need is the argument. Argument, look for what's by itself. 9. Now, for now, that's okay. That's what I would expect you to leave it like, because you don't know anything else yet. But in a second, you're gonna know something, and you probably would never see something actually written like that. Okay, but that's good if you get that far for now. Any questions on that one? All right. So just to make sure we remember, let's try one more. Changing back to exponential. Okay, so one of the first type. All right, so Cal, if I want to change that to exponential, what's one thing I could write down?
Do -3.
Okay. What is that -3 going to be?
Alone.
So logarithm always equals the exponent. So that's going to be an exponent on something. Can somebody tell me what that's going to be an exponent on? Yep. E. E is the base. And what ends up by itself on the other side? B, because that's the argument. B is the argument. Again, B is kind of like 12. It's the number that you'd be plugging into that function. I haven't given you guys a number to plug in yet. We'll try one soon. There's your answer. Now I'm going to talk a little bit more about E. Okay. If you look at my calculator or the ones that you guys use too, it has different numbers programmed into it. Most people know this one. Pi. That's not pi. Pi, 3.14159. So pi. It's a common number. We use that a lot anytime you're doing stuff with circles or spheres. Well, there's another number on the calculator, and it is called E. E is not just a random letter. In math, E is a number, 2.718. Okay. And it looks like it keeps repeating, 1828, 1828, but the next numbers, it's not 1828 again. I don't know what the next number is, but it doesn't keep repeating in that pattern. We don't use E as much because it's used with logarithms. Most people don't use logarithms as much as they use maybe like volume of a sphere, or surface area, or perimeter circumference of a circle. That kind of stuff you use pi. Okay, much more common. But E is actually the number 2.718. So this, when I write E to the negative third, I could actually figure out what that is. E to the negative third. They didn't ask me to, but that's what it is. It's about 0.05. 0.05. Right? So it's important, anytime we're doing something with logs, you would never see me use E as a variable. Ever. Because E is the number 2.718. It's kind of like in geometry, you would never use the Greek letter pi as a variable. No. Because pi stands for something, 3.14. When we've done trig, we've used Greek letters, like maybe alpha, beta, but you never saw me use the Greek letter pi for an angle. No, I wouldn't do that. Because pi means 3.14. It's just something in math that we do. Alpha and beta don't mean anything. They could be any value you want, but not pi. Pi can't be any value you want. It's 3.14. Okay. The same with E. E is always 2.718, and it keeps going. Okay. All right, so now let's try to solve that equation. Now, I haven't shown you how to plug anything on a calculator in yet. So that means something here has to work out nice. It's not going to be a problem when you need a calculator. Okay. Any suggestion on what I could try to do to that to solve it?
Change it into converters.
Yeah. The only thing we know how to do right now with logs is change them to exponentials. The only thing we know how to do with exponentials is change them to logs. Let's just try it and see if something happens. Let's start with my base. So what's my base here?
2.
Yep. Base is 2. And Jason, logarithm always equals what kind of number? Yep. So logarithm, in this case, is equal to x. That's my exponent. And Emily, what's the name of the 16 again?
It's the argument.
It's the argument, and if you argue, it's going to end up alone. And now that's the equation that we have to solve. Now, I picked these numbers on purpose, so 16 is a power of 2. 2 to what power gives you 16? 4. Yep. Now, if you were thinking 8, you were thinking this. 2 times x equals 16. No, that's different. Okay. 2 raised to the power of x. In that case, 2 to the 4th power. 2 times 2 times 2 times 2. And that's it. Question on that one? Let's try this one. Pretty much the same setup. We've got a number for the base, a number for the argument, and a variable on the other side. Okay, without me going through it, anyone think they can tell me what the answer for x is? Yeah. So what is your answer?
2.
2. Yes. The answer here is 2. Okay, how you get it? 5 is your base. X is your power. 25 is the argument, ends up alone on the other side. So now you're just asking yourself, 5 to what power is 25? 5 to the second. So these are kind of like the ones that I showed you guys at the very beginning of class. Except for now, I'm picking nice numbers. By the end of the week, I can pick any number. It doesn't have to be 25. Question on that one? Let's try this one. So we got to remember what happens when you have fractions. Okay? Fractions with exponents. Okay, we'll go through this one carefully, but it's not too bad. Okay, so we know 3 is the base, x is the exponent, and the argument is a fraction. It ends up by itself. Now, solving that is pretty much the same as solving that. Look at the one on the right first. 3 to what power would give you 27? Yeah. Yep, 3 to the third power. 3 times 3 times 3 is 27. Now, this isn't 27. We don't want 27. We want 1 over 27. So, anybody remember what kind of number your exponent has to be to give you a fractional answer? Yep. Negative. Has to be negative. Yep. Anytime you use a negative exponent, that causes the 27 to go to the bottom. Okay. So here, x is negative 3. And just to write it out, in case you look back and you forget this, 3 to the negative third power means that. A negative exponent causes it to flip. It goes to the bottom of the fraction. All right, so it's still 3, just like this one, except you want it to flip, so you got to put a negative in front. All right. And other thing that's nice is you could check that. Right? We're supposed to get 1 over 27 as the answer. So let's try what we got. 3 raised to the negative 3 gives me 0.037 repeating. Let's change that to a fraction and see what it is. 1 over 27. So I just plugged negative 3 in to check my answer. And I got 1 over 27 on the left. And it's supposed to be equal to 1 over 27 on the right. Perfect. Questions on that one? All right. Okay, I already kind of told you about this. But e, again, it's actually a special number. When you're doing algebra 1 stuff, it's okay if you use e for a variable. Okay? In fact, as long as you're not in the context of a logarithm problem, e can be used as a variable and there wouldn't be much confusion. Okay? But in logarithms, don't use the letter e. Okay? We don't want to use that. Unless you mean the number 2.718, then you use it. But if you need to pick a variable for something, pick something besides e. Pick d. Don't use e. So, I told you guys earlier that we wrote down something that you usually would not see. Let's see, it was the answer to this problem. Example B. Log base e of 9. So, when you guys did this one, you didn't know that e was actually something special. Okay, we just did the problem. Now, whenever you see log base e, in math there's an abbreviation for that. They shorten it up. The abbreviation is lowercase l, lowercase n. So if you see log base e, something like that, it's exactly the same as writing that. Those two things I circled are the same. Okay, why do they do that? Well, it's just a little shorter. I guess log base e is 4 letters, ln is 2, so it's half the amount of letters, I guess. And the ln is not just random letters. When you have a base of e, that's called a natural log. That's what the ln is, natural log. So then you might ask, why isn't it NL? Natural log, NL. Why is it like ln? I don't know. Just ln. So that's what they call it, ln. Okay, there are 2 logs in math that have special names. One of them I just showed you. If you write log and the base is an e, that is called a natural log. Okay, on your calculator, there's the button for it. Lowercase l, lowercase m. ln. Okay, there is no button on the calculator that says log base e. And I'll mention the other type of special log in a second. Okay, so now that we know what ln means, I want to change this to an exponential expression. Now, what you kind of got to be careful about is the base. The base is hidden. Remember what we just said. ln is hiding a base of what letter? E. Okay, the base is hidden. So you have to know what ln means. Right? So Andrew just told us our base. E. E is the base. Justin, what's my exponent? 8. Logarithm equals the exponent. All logarithms. This is a natural logarithm. It's still a logarithm. Logarithm equals the exponent. And Courtney, what ends up by itself?
The 8.
We already used the 8.
That was the x.
The x. Remember, the x is your argument. Now, did the directions say to actually change e to the 8th to a number? No. It just said change it to an exponential expression. Didn't say to do it out. So you're done. If it did say to do it out, I would just go to the e button on my calculator and then put an exponent of 8. And my calculators do have the e button, so it's no problem. Try this one. It's pretty much the same kind of thing. ln of x equals 12. Pat, you think you could tell me the whole thing if you change that to exponential expression?
The exponent of 12 equals x.
Perfect. Done. E to the 12th equals x. And just to show you how you type it in, every calculator is a little different. On mine, I have to press second, and then mine's the divided by sign. Yours is probably different, okay, unless you have a calculator like that. And then exponent 12. Okay, so if they asked what the answer was, it's what is that? 162,754. Okay. Questions on that one? Okay, so first log I told you guys about that had a special name was the natural log. That's when the base was in E. The other special log is when the base is a 10. That is called a common log. Other than those 2 names I just told you, there are no other special names for logs. Like what would you call it if the base was 5? You just call it base 5. There's no name. Okay, but base E is natural log, base 10, common log. That's how you write common log. Log, base 10 of 5. That's also how you can write a common log. Log 40. Looking at my second example there, what does it look like is missing? What does it look like I didn't write? Okay. The base, I didn't write the base. That's fine. Okay. It's kind of like, if you look at that, you may say, well, the number in front's missing. No, it's there. You don't write it. Like what number is always in front of a variable if you don't write it? 1. Well, same idea. If you write a log and you don't put the base, we assume it's a 10. Just like if you put an x and you don't write a number, we assume it's a 1. So when I press the log button on my calculator, and I type in like log of 50, it didn't put a base. Since it didn't put a base, it's doing the common log. So by pressing a button on the calculator, there are only 2 logs that it can do directly. It can do base 10 or base e. So if I asked you to do something like log base 3 of 12, well, there is no button for base 3 on the calculator. There's base 10, there's base e. I'm not saying you can't type this in. You can. But I'm going to show you that some other time. Yeah. So any questions on what a common log is? Just base 10. All right. All right, so let's see if we can solve this one. Most of the algebra you're going to need for solving equations this week doesn't go beyond algebra 1. Quadratic formula, I think, will be the most complicated thing that will come up. Yeah, algebra 1. Okay. So, in order to solve that, we're going to try to change it. How about, Alyssa, if you're looking at that equation, is that log or is that exponential? That's log. Got the word log. So what we're going to do, we're going to change it to exponential. Now, don't get confused because it looks like there's more stuff. No, there's only really 3 things there. The base, all of that is the argument, and that's the number on the other side. So, 3 things. Bless you. So, Sebastian, I just said it, but what's my base there? 3. 3. Yep. 3 is my base. And Grace, logarithm always equals what kind of number?
The exponent.
Exponent. So my exponent is a 2. So 3 to the second equals 4x minus 7. 4x minus 7 is the argument. And now just solve that equation. Get x by itself. Okay. What's the first thing you do there to get x by itself? Okay, we can add 7. Add 7. Add 7. Now we should do 2 things at once. What's 3 squared? 9 plus 7? 16. So the other thing I was thinking to do first was just to simplify the exponent. But if you don't, just do it all in one step there. And Max, what would be my last step? Okay, so how do we get x by itself? And where do you want to divide it? Yep, perfect, on both sides. And what does that give me for x? 4. Yep. That's it. That's That's your answer. Right? So when you first look at it, it might look like kind of a confusing problem. Walking in today, you probably would have had no idea how to solve it. Now when you change it to an exponential, it turns into a very simple algebra 1 problem. Any questions on those steps? Okay, let's take a look at this one. Okay, a little bit different. Look where the variable is. The variable is in the base. In example A, the variable was in the argument. So I just switched where I put the variable. It's not going to change your first step in this problem at all. So Elizabeth, what would be my my first step?
Well, you have to convert it in exponential equation.
Yeah.
X squared.
Perfect. So we change it to an exponential. X is the base. Logarithm equals the exponent. Argument ends up by itself. Now, we have x to the second power equals 64. I got to get rid of that second power. So what cancels out squaring? You square root it. Yep. So take the square root of both sides. That's gone. Square root over there. What's the square root of 64? 8. You know. I'm not saying the answer is always going to come out nice. If you've got the square root of 70, which is not a nice number, use your calculator. Type it in. Okay, question on that? Okay, so last one. So let's see, we had the variable in a log problem in the argument. We had the variable in a log problem as the base. Now we've got the variable in an exponential problem. So now I'm starting you off in the other form. It still doesn't change the first step. First step is usually always change it from what they give you to the other one. Okay, so what form is that? Is that logarithm or exponential? It's exponential. The only way it would be log is if you see the word log or ln. Those both mean log. Natural log, common log. Right? We don't have either one of those. So we're going to change it. All right, to change it to log, first thing we do is write down the word log. Steven, what's my base here?
105.
No, not 5. Where do you look for the base? It's always the thing that's compared to everything else. Yep.
Base.
And how do you know that?
Because oh, because the 2x is the exponent.
Right, because the 2x is the exponent. The e is lower, right? So you look for the thing that's lower, and that's always the base. So log base e. Logarithm always equals exponent. Alex, what's my exponent here? 2x. Now the only thing left is the 5, and that's by itself because it annoyed everybody, and it's going to be the argument. Now, what could I do there before I go any further? Something I can shorten up. Yeah.
Well, since E is a number, technically you could type that into your calculator for the whole right side.
We can. We're going to be able to type something in. Yes, we're going to use the calculator in a second. But something I want to do first. The way that's written, you never see that. But how can I shorten that up? Yeah.
ln.
Yeah. Change this to ln. That's also going to give you a hint when you got to type it in on the calculator what button to press. Now, before I type anything in, I still don't have x by itself. I've got the 2 next to it. So how do I get the 2 on the other side? Yep, divide by what? Divide by 2. Divide by 2. That's gone. And x equals the ln of 5 over 2. Now, if they want an exact answer, there you go. If they want a decimal, we got to type it in. So we've got ln of 5. Now, do you think it's important I close my parenthesis or it doesn't matter? Yeah.
Probably close it.
I should close it. If I don't close it, it's going to do this. I don't want to take the natural log of 2.5. That's not what I'm going for. I want the natural log of the number 5, and then I want half of that when I'm done. I want to divide it by 2. Okay, so if you don't close the parenthesis, it'll mess up. That's the answer. 0.805. So it just depends if they wanted a decimal or leave it as an exact answer. Okay, any question on that? No? Okay, nice. Good job. So what I'm going to do, I'm going to give you guys a little bit of time to do the homework. You might get it done. If you get it done, then there's no other homework tonight except for that. Okay, so that's page 473, and that's all evens. Every problem. 10 to 16, 22 to 28, 34 to 38, 92 to 98. There are some you will need a calculator. So, would anybody that's going to work on it, anybody need a calculator? If they don't have one. Okay, if you need one, I'll take them out. Otherwise, you can use your phone as a calculator because it's not a test or anything. That's fine. Okay, I'll also unlock your cabinet, so if you need a book, you can grab that too. Also, my extra help day this week will be Wednesday, since the test is Thursday.